Hi everyone and welcome. My name's Cyclic Hotline and this video is going to be an introduction to the autopilot systems for the H145 module by Hype in Microsoft Flight Simulator 2020 and latterly 2024 as well. This main purpose is so that you can operate the aircraft IFR. I've been a professional pilot in real life for about 15 years, operating in HEMS, offshore, IFR and including the H145 type as well. So the systems have been pretty well modelled in this, but there are a couple of little workarounds that we need to use and even a couple of things we need to ignore to make sure that this goes smoothly when we use the autopilot in the H145. But we'll cover those as we go. So without further ado, the most important part is understanding the AFCS strip. So automatic flight control system strip, the ALT, heading and airspeed, and all the other little boxes which come up at the top. So first of all, we have three distinct boxes. The left box is our collective channel. So this means that whatever is in that box will be controlled by the collective. Heading is in the roll and yaw, so anything in the middle box will be a roll and yaw. And lastly, the pitch channel on the right hand side. So there's many ways we can interact with this. So the most obvious one in real life would be to use the actual autopilot management systems here. But it's quite difficult for me to faff with this, look up and make a concise video. If you want to use this, by all means, that's how we'd actually use it in the real thing. But for the purposes of this, we're going to be using the iPad so you can directly see the changes happen as I make them. So in the iPad, doesn't matter what app you're in, up at the top, if you click on the time, we get doors, autopilot and lights. I'm going to leave it on the autopilot. I'm going to use this little arrow here to open up our collective and cyclic beep trim points. So you can map these to your HOTAS if you want, so that's the cyclic beep trim, that's the collective beep trim, and that's how you'd interact with them in real life. But as you can see now, I can just press up here and the airspeed will increase from 80 to, in this case, 90 knots. Perfect. So right now we've commanded the aircraft to fly an altitude of 2,000 feet, a heading of about 015 and a speed of 90 knots. So how do we get this to change? So it's really important with helicopter IFR to be proactive and get things ready and do things in good time. In particular with this simulator, do not ask too much of it at once because it won't like it. So I'll give you an example of asking too much of it at once. Let's change the altitude acquire. So this is how we pre-select the altitude. Once the little bug goes off the screen, we then see it climbing. So let's set 3,500 feet, roughly. Sometimes it doesn't select the exact one. And let's engage it. So engaging ALT.A. So vertical speed is engaged, altitude acquire is armed. The real aircraft will just start climbing, but this one we actually need to start inputting some vertical speed to get it to go. So there's your vertical speed bug here. Let's set 1,000 feet per minute. It's going to draw in a load of power and it's going to climb us 1,000 feet per minute to 3,500 feet. So let's ask for a bit more. Let's ask for 1,500 feet per minute. At this speed that might not be too bad, but now I'm going to be a real idiot. I'm going to increase this to 120 knots. The real aircraft does not do this, but the simulator will overtalk, bing and bong like you wouldn't believe. Do not touch the controls. I have not touched the controls at all yet in this entire sortie. Leave it to do its thing. You're going to get warnings, rotor RPMs dropping. If you touch the controls now, it will confuse the living hell out of it. Let it do its thing. So we can do things to help it. We can reduce the vertical speed, we can bring the airspeed back again. Just be nice to our airframe and don't give it too much to do at once. Okay. So once we enter within 300 feet of 3,500 feet, so in this case 3,200 feet, this will change to ALT. So there's 300 feet, ALT. So we're no longer in the vertical speed mode. You can see down here the ALT button has captured, and we're now going to level at 3,500 feet. If you were IFR, you would monitor this like a hawk to make sure it's definitely happening. But right now we're VFR, nice sunny day, and we can move on with some of our other things. So as you can see, you can adjust the heading left and right as well. So let's go into heading of north, and you can do that with this roller as well should you wish. But I want to talk about the vertical speed heading and track flight path angle butterfly. So you can move this by pressing this button, or there's the actual butterfly here. So if I just engage track IR so I can show you properly, as I look left, you can see vertical speed and heading. If I click the butterfly, it reveals flight path angle and track, and we are now holding track automatically. So how's this different from heading or vertical speed? So with this nice crosswind, you can see now that the track diamond, the brown diamond, our route that we're taking over the ground, so you can see if you look out the window, we're sort of heading off in this direction because of the crosswind. It will hold the track rather than our heading. This is quite useful, so putting the brown diamond onto your localizer, for instance, means you'll hold the localizer rather than putting your heading onto it. Or if you're flying up a valley and there's complex winds, you can put the track, it'll track up the valley rather than having to constantly alter your heading. But invariably we don't use it a great deal. And now for vertical speed, I'll put in vertical speed mode for the flight path angle. So let's get another outer quire and let's descend a bit. Let's get down to let's go a bit further. Let's go 2,500 feet and engage. Well, now, as you can see, we need to give it a little bit of help to get it going down. So the vertical speed still comes up, but now it's come up as a percentage and a degree that you're descending at. Okay. So if you were climbing out and a SID requires a 5% climb gradient, you could use this if you wanted, but it's not used in helicopters much. Okay, so let's go back to just holding an altitude. So alt's captured here, but it is suddenly rocketing down for reasons unknown. So if the aircraft does stuff that you didn't want it to do, change it. Let's deselect altitude. It's going to have a right wobble about that. And let's reselect altitude at somewhere sensible at 3,200 feet. Right? If the aircraft does something you don't want it to do, take action. This is not a perfect system. Helicopters are not like planes, and Microsoft Flight Simulator does not do this well. So Hype have done really well to model this, but it will throw some strange stuff at you, like the overtorques, like every now and again the autopilot not doing what you'd expect. So I'll come on to something else as well, is that when we have all three of these, this is known as 4-axis. Appreciate that doesn't make a great deal of sense, but effectively collective, roll yaw and pitch is 4, but there's only 3 channels. So we always want, when we're using automation, to either have all 3, but don't ever be in a situation where you're missing the collective channel. Don't ever be in a situation where you're missing the pitch channel. The only time it's acceptable is to be missing the roll yaw channel. So let's deselect heading. Now, the only time this is useful is, let's say you're flying HEMS and you're doing a rescue and you want to have a look for a landing site down there. So let's use the trim, see, this here is now attitude, not heading. So let's move the trim over to 20-degree angle of bank. And now it's holding 100 knots, 3,250 feet, and you can look down, and you can look down forever, and it will hold that speed and that altitude all for you. That's the only time you'd ever really use what's known as mixed mode flying. So let's use the trim again. I'm using this on my HOTAS now to level out, and now we can select heading, and it will select whatever the heading we were on. Okay, so let's use the GTNs. This isn't a guide on how to use the GTNs. It's much like some of the other modules. So let's use nearest, airports, and let's go to Filton, which is 3 nautical miles away. After Filton, we can use the direct to button. It will select Filton because we're on the waypoint page. Let's activate, and now we can see that the FMS has drawn a line going towards the airport. So this button has now appeared. So the nav source is FMS. If we were to click away, it would be nav source ILS1, ILS2, and now we're on FMS, and it's in blue, meaning not engaged. We're in heading. Let's click couple to this. It goes green to let you know that we have coupled to the FMS. The decouple button is now visible, so we would press it again, it would no longer hold nav, and nav has appeared in the roll yaw channel. Now you can see by looking at this screen here that the line it's drawn has come from where we pressed it, so it's going to come and turn around and select this, and it's all a bit of a faff. So if you want to make it a bit of a neater turn, as we come around the corner, within 30 degrees or so, direct to Filton again, activate, and it will draw a newer line. It always appears very nicely on the GTN, and then it takes a few seconds to appear on the NavD. And then now we'll roll out without having to do that. And lo and behold, there's filter. So lastly, we're going to be looking at the automatic hover modes. And this is really useful in poor weather conditions at the bottom of an ILS. And it's really good to get a handle on this and have a practice. So let's set something sensible. So this is a bit of a pain, but you tapping down on ALT.A and using this thing, it is a lot quicker to just use the ALT.A roller down here. So let's get down to 500 feet, say, well, actually the airport's behind, let's get 1,000 feet, and we'll engage ALT.A. And vertical speed and get airspeed. Started a bit of a weird climb, again, sometimes this does this. I haven't asked a lot of the sim, but sometimes we'll have a moment. And let's get the vertical speed going down, and let's get the indicated airspeed back to VY, this little blue line here. So VY being your best rate to climb. But it's nice safe IFR speed, for instance. So it's going to take us a while to get down, so let's preface what we're going to talk about with our automation. So cruise height is currently unavailable because it's based off of radio altitude hold, your rad alt. So as you can see, we are descending through 2,300 feet. I think the max height it can hold is 2,000 feet anyway, so there you go. It's now just become available. We're not going to use it just yet. The real aircraft have some protections involved with decision height, so if you'd asked it to fly a rad alt hold at 100 feet and descend to there, but your decision height is 300, when you click it, it would automatically set 300. Your decision height must be lower than your cruise height in order for it to engage, and we'll talk about that as well when we do the IFR sorties. So your cruise height is your radio height, and it's a lot more accurate than your bar alt once we're nice and low. And then we have two effectively hover modes, auto hover and ground speed hold. Auto hover does what it says on the tin, it takes you straight to the hover, and ground speed hold will hold whatever ground speed you have when you engage it, but then you'll have the ability to alter it. So let's get turning back to our airfield. So we're going to use this not going to the nav, so I'm going to decouple nav. Everything's gone blue to let you know that it's not coupled a minute. And again, I'm just going to use this trimming into the turn. Let's set 30 degrees, and you can see, we're still descending to 1,000 feet. We're holding VY perfectly. We've got good speed. We're not entering into a dive. We're not losing situational awareness. It's a great system if you need to do orbits or tight turns and stuff. So while we're here, we're now 800 feet. Let's select cruise height instead. So cruise height is engaged at whatever height we're at. And let's face down the runway. Let's bring the speed back even more. Now just play with this and get used to all the different things it can do. It's a very, very powerful autopilot. Again, we're not even using heading, it's just holding all this for us, decelerating. Again, I'm not asking a huge amount, if you ask a lot in the collective and pitch channels at the same time, that's when it really has a problem. So let's engage hover. GTC H and H. And we are now decelerating. So this button changes the HSI. So we're currently in HSI mode, sector mode, and the next is HOV or hover. There we are. And as you can see, that green ring means it's trying to achieve 0 ground speed in every direction. And lo and behold, we're nicely in the hover. And everything is all green. So let's descend. So the cruise height, we can use our collective beep trim to come down if we want, or the roller is a lot faster. So let's get it down to 50 feet. This will take a while, on cruise height, but that's okay because we can demonstrate some stuff on the way down. So it is a lot quicker than with the roller. 60 feet is fine. It won't do more than 300 feet per minute on cruise height. That's vortex ring state protection. So effectively, don't worry about using this. We're going vertically down. It does this so much better than I can, especially in a simulator. So let's look at some other stuff. So if I were to hold forwards on the cyclic beep trim in hover mode, it will, start to eke forward. But when I let go, it'll come back to being in a hover. Not in the position you were. It will just try and maintain a hover. If you use the beep trim left and right, it will slide to the right, slide to the left, so good for small incremental adjustments. And then on the collective beep trim, your minus and plus is fairly obvious. It changes the heading. Now, when we use ground speed hold mode, if you want to go from hover to ground speed hold in this simulator on the real aircraft, you will have to click it twice because it will knock hover out. So click once, click twice. It almost always enters into a right drift. Not quite ever worked out why yet, but now you can see that we've got the donut and some numbers. So let's get that number going forward. So let's set 8 knots forwards, which is a nice hover taxi speed. So there's 8 knots set on the hover display, and 0 to the right. But are we still crabbing to the right a bit? We are. So let's get that coming left a bit. So I've just entered into pitfall number 1 with GTC, the ground speed hold rather than automatic hover. Over a certain ground speed, left and right becomes heading. Look how it's adjusting the heading. So yaw will also adjust the heading, but once you're through, I believe, 5 knots, it will adjust heading, not slide. So if I bring this back to 5 knots ground speed and use this, now it goes back to sliding. See, I've set 5 knots forwards, 10 knots to the right, back to 0 so that it stops somewhere in the middle of the runway. But if I set 10 knots forwards, because it doesn't want to translate left and right, then the cyclic beep trim now becomes heading again, not a translation. And then the last thing with ground speed hold rather than automatic hover is that we've got 0 left and right, 10 knots forwards. If I set this to 0, it goes automatically to the hover mode for you. So you'd have to re-engage ground speed hold mode if you wanted to use that functionality. Okay, so let's beep cruise height all the way down. So you can set 3 feet. Great if you want to land just by lightly pressing the collective. Not so great if you want to actually maneuver around. I would suggest being at least sort of 15 feet if you want to maneuver, which we're going to set now, and try and stop it from drifting. So we were in automatic hover, but because initially we'd selected ground speed hold, once I actually ask it to translate left, it goes back to trying to hold the numbers rather than acting how automatic hover. So it's just a bit of a peculiarity of this system to be aware of. Just make sure that whatever's up there is what you want it to be. So let's actually just select hover now. So because I've selected hover itself, it will hold hover like it did before. When I go forwards and left and right, it will not bring up numbers like in ground speed hold mode. So if we imagine that it's all nice and IFR, which is what we're going to be doing soon when we do an IFR sortie, we're going to depart now. So I want to fly runway heading, and I want to go to 3,000 feet. So I'm going to use the roller again, purely because it's a lot faster. So let's use the roller to set 3,000 feet on our ALT.A. Anything close will do, because it often does not select exactly 3,000 feet. So 2990 is fine. We'll fine tune that at the top with the normal alt mode. So we've got an ALT.A at 3,000 feet. I want to fly runway heading. Now the wind's off to the left, so if I fly this heading at low speed, I'll kind of drift off to the right. So let's use the butterfly to change that to track. Okay, so it should fly runway track. Let's get it onto 090. This is still technically a heading mode in hover. It doesn't use track. Track only really comes into effect once you're through about 40 knots. So we're going to use go around. So the go around function you can use any time if you want to keep climbing. Great at the bottom of an ILS if you don't become visual. But from the hover, it will just start climbing. It will try and attain 1,000 feet per minute, which, because we're in track flight path angle here, it will show a percentage and a degrees, but we can use the vertical speed indicator to see it aiming for 1,000 feet, and it will achieve VY. So go around. So go around, ALT.A captured, or sorry, not captured, armed, track for runway track, and go around in the pitch channel as well. So it's increasing speed to 70 knots. It's climbing at 1,000 feet per minute, but in this case it's just showing it as degrees and gradient. And as you can see, it's trying to hold the track of the runway. We went off to the right a little bit. I think that's pretty good. Once it reaches these parameters, 1,000 feet per minute, and it's close enough to VY, Go around disappears, and now we see what was happening all the time behind it, which is our flight path angle and indicated airspeed hold, and an ALT.A of 3,000 feet. So if that was your clearance on departure, you barely had to do anything, just press one button as long as you had everything set up and ready to go. So as you might have guessed, I've barely touched the controls for this entire video, 20 minutes worth of me just using autopilot to maneuver the 145 around. So that is the crux of a lot of what we're going to be using. Understanding how it works and having a play with it means that when you go and flying IFR, you're better prepared to use the automation to your advantage. So the next few videos will be doing an actual IFR sortie, using the automation, setting up the screens, and having them displaying the information you need to fly around. Okay, well, thanks very much for watching. Please leave a like and comment. Got any questions? If there's anything you'd like to see, please let me know. I can always make another video. And yeah, we'll see you hopefully in some IFR sorties. Thank you very much.